All right, I want you to imagine an organism that can survive being boiled, crushed, and then blasted with enough radiation to sterilize a hospital. These aren't aliens from some sci-fi movie. They are microscopic superheroes living right here on Earth, and they are about to completely shatter our definition of what life can endure.
So that really makes you wonder, doesn't it? What are the absolute rock-bottom limits of life? We're not just looking for where life is comfortable. We're hunting for that razor-thin edge of survival.
Exactly. When we think of life, we picture lush forests, vibrant coral reefs, all these comfortable, nice places. But what if biology's true masterpieces aren't found in paradise, but in hellscapes that would kill you or me in an instant? So let's do it. Buckle up. We're about to go on an expedition to the most inhospitable corners of our planet to meet these microscopic titans face to face.
Our tour starts miles beneath the surface, in places that somehow manage to both crush and cook whatever dares to live there.
Okay, we're diving miles down into the abyss, all the way to these volcanic chimneys on the ocean floor that are just spewing superheated water into the freezing darkness. It sounds like a vision of hell, but believe it or not, it's teeming with life. And when I say superheated, I really mean it. We're talking 400 degrees Celsius. That is literally hot enough to melt lead. And yet, right there at the edge of these searing vents, entire ecosystems are just flourishing. So how is that even possible? Well, these microbes have a whole toolkit of superpowers. For starters, their cell membranes are built with this special, heat-stable fat that just refuses to melt. They've also got these things called chaperone proteins that act like tiny bodyguards, physically holding their other proteins together to stop them from unraveling in the heat. And since there's no sunlight, they don't do photosynthesis. Instead, they do chemosynthesis. They literally eat chemicals, using toxic sulfur for energy. And they do all of this while being squeezed by pressures that would flatten a submarine like a pancake. And this isn't just an ocean thing either. Get this. Kilometers beneath our own feet, there's a massive, deep biosphere of microbes living in solid rock, totally cut off from the sun for millions of years, just slowly munching on minerals and hydrogen gas for energy. Okay, so from the extremes of heat and pressure, our journey now takes us to some of the most corrosive, toxic chemical cocktails on the entire planet. I mean, the range of what life can tolerate chemically is just staggering. On one end of the spectrum, you've got microbes living in Spain's Rio Tinto, a river so acidic it has the same pH as your stomach acid. Then, on the other end, you've got places like California's Mono Lake, where the water is as alkaline and caustic as household bleach. And they survive because they're absolute masters of defense. In the acid, they have membranes that are basically proton-proof force fields, and they have these little pumps that constantly bail out any acid that sneaks in, keeping their insides perfectly neutral. In the alkaline water, where there aren't enough protons to power their cells, they just re-engineered their whole energy system to run on sodium instead. It's an absolutely incredible biochemical workaround. And the same kind of crazy ingenuity applies to salt. In lakes that are 5 times saltier than the ocean, an environment that would suck the water out of most cells and kill them instantly, these so-called halophiles thrive. They stop themselves from drying out by packing their own cells with ions to balance the pressure. They're actually the reason these lakes have those famous, otherworldly pink and red colors. All right, for our final leg here on Earth, we're visiting places that are defined not by what they have, but by what they lack: warmth, water, and protection from cosmic rays. So, in the coldest places on Earth, life doesn't just put up with the freeze, it rewrites its own chemistry. Microbes in Antarctic ice sheets actually produce a biological antifreeze to stop deadly ice crystals from shattering their insides. And their membranes? They're made with unsaturated fats. Think olive oil versus solid butter, just to stay fluid and flexible, even when it's so cold that all the chemical reactions of life should just grind to a halt. But when it comes to just pure, unadulterated toughness, very few can match this next microbe. I want you to meet Deinococcus radiodurans, better known by its fantastic nickname, Conan the Bacterium. So why the tough guy name? Well, it can withstand 5,000 grays of radiation. To put that in perspective for you, a gray is a unit of radiation dose. Just 10 grays is a fatal dose for a human. This microbe can absorb a blast that should shred its DNA into confetti and just keep on going.
So here's how it pulls off this miracle. First, the radiation blast literally pulverizes its DNA into hundreds of pieces. But then, and this is where it gets crazy, this incredible emergency repair crew of proteins kicks into gear. They hunt down every last fragment, protect them from more damage, and then use multiple backup copies of the genome, like a blueprint, to flawlessly reassemble the entire chromosome. In a matter of hours, it literally rebuilds itself from its own rubble. It's amazing.
And finally, let's go to the driest place on Earth, the Atacama Desert. Here, microbes survive by pretty much shutting down. They go into this dormant state, almost completely dried out, just waiting for the slightest bit of moisture, sometimes just absorbing it right out of the night air, to rehydrate and come back to life. Okay, so these incredible survivors aren't just biological curiosities, they completely redefine where we should be looking for life beyond Earth and what that life might actually look like. I mean, think about Mars. It's a freezing, irradiated desert. Sounds deadly, right? But we just met microbes that thrive in the extreme dryness of the Atacama, and others, like Conan the bacterium, that would laugh at radiation thousands of times stronger than what's on the Martian surface. Or what about Jupiter's moon Europa? Scientists think it has a vast liquid water ocean under its ice shell, maybe even warmed by hydrothermal vents. Well, we've already seen that Earth's own abyss, with zero sunlight and crushing pressure, is home to entire ecosystems powered by the chemical energy from those exact same things. And it's the same story for Saturn's moon Enceladus. It's got a subsurface ocean, completely shielded from radiation. That's a perfect parallel to the deep rock biosphere right here on Earth, where we know for a fact life can survive for eons, powered by nothing but geochemistry. So all of this brings us to one final, unavoidable thought. The microbes we've met today prove that life isn't this fragile, delicate little accident. It's tenacious, it's adaptable, it's an opportunist. It finds a way. So if life can conquer every single impossible environment here on our home planet, what's really stopping it out there?